Right. Yeah, I think I'm live. Let me just test something. Gonna play back. So I'll pause the music. Right. Okay. Yeah, I think yeah, it's good enough. All right, cool. So, to anyone watching this, anyone at all, what I will be doing is creating Minecraft in Opengl from scratch. And I'll just show everything from the project setup, cmake, and this is a browser which is specifically for the coding, finding stuff, and yeah. So that is what I will be doing. So we got this tab, and we got the graphics tab, and then if I need to do some drawing, then I will just be doing that in Obsidian. As you can see, I've got League of Legends on the bottom as well. So yeah, that's interesting. Let me just check everything's working. Okay, yeah, it looks like things are working. Just need to check the quality as well. Yeah, that will do. All right, cool. So we might as well just get started. Right, so first things first is we've got to set up the project. So I'm going to be using cmake, and I'll just talk through how to use cmake and where we're going to start. So start by just creating a main.cpp, and you'll see that I don't use IntelliSense, which is just mainly personally so that I can remember C++ specific syntax. So we'll just create a main function to start with, just printing stuff out. Just because we want to test it. Right, then let's create our cmake lists.txt. Let's create our project with first things first. In cmake lists, first thing you always have to do is set the cmake minimum required. It's required by cmake before you can do it. Do it like this: cmake minimum required function 3.20 or whatever version here. This is the major version. This 20 is the minimum version. Min version. You can also specify a range if you want, like 3.30, by doing ellipsis like that. This is the keyword which you need, specify the version. Then we name the project, which is going to set some internal variables for cmake. We will just be calling it like main or something. Now we can add an executable. Add executable, and we'll call our executable main. So let's change our project name. It makes more sense to call it Minecraft, and we'll add our source file, which is the cpp. I don't know why I keep saying ccp. Yeah, so that's that, and now we just need to check if our cmake list thing. So let's compile. So we'll open up our console. And let's specify that the source file is in the current directory, and we want to build out to a build folder. And this is basically just going to create the config for the build. We're not actually compiling anything yet. So they're just build files, and then we need to invoke the build by specifying the build flag like that and telling it where to compile all our stuff. So put it in the build. Right, and then it will be in the directories build /debug /main. We run this, it says hello world, the project is working, and we are set up with a cmake file. Right, so next thing I'm going to do is going to create source directories, put this in, put my thing in there. We'll just create an include directory in case any includes happen. We'll keep cmake list.txt there. We'll also create a git ignore to ignore our build directory, because we don't want the build directory being pushed to our git, because it will just be taking up a lot of space, and later when we pull in third-party dependencies like glfw, you'll see that the build, their source files get sent into the build folder when we are fetching them using cmake. And if we add that to the git, then it will just be adding all those build files which stay the same all the time. So there's no need to really version control those because they're never changing. So let's initialize the git repository, create an initial commit. We'll call it started Minecraft stream. Oh, we've got to stage our files. Okay, we'll commit, and then we'll clear our thing. We'll do a one-line log. And you can see we've got our first commit. So now we have basically set up a C++ project. But we haven't really done anything with glfw, we haven't done anything with OpenGL, right? So the way that OpenGL works is there are different implementations of OpenGL. Some are, for example, open source, and I'll show you one right now. So if we take a look at MesaGL, we'll see that Mesa has an OpenGL implementation, and basically these people, I don't know the name, like something consortiums, create a OpenGL specification, which you'll see here. And it is the graphics spec, which is telling everyone what the implementers need to include to follow the specification. And it is written in a C style, so all the functions specified are in a C style. Just need to turn the music down a bit. For example, let's find one called GL viewport or something. GL and buffers. Don't know why this is not working. I'll just scroll down till I find something. Okay, so here, so you can see, oh, because it's not GL. In the spec they say vertex, so they just omit the GL. So they specify it in a C style thing, and then implementers have to go away and implement all these functions, and then they will package all those functions into drivers, OpenGL drivers. MesaGL is one of those OpenGL drivers that they have made available, which is open source, so people can commit on, well, no, they won't necessarily commit because they won't really have access, but it's open source, so you can read the code, you can read the source files. NVIDIA also has an OpenGL driver, which is proprietary, so it's controlled only by people in NVIDIA. No one outside of NVIDIA can see that. And part of the way that I think they actually build up MesaGL is by reverse engineering the NVIDIA drivers to see what they are doing. But I'm not really sure if it's necessary because OpenGL spec isn't necessarily too hard, too complicated. and it's quite descriptive. So that was just a tangent, but the point is that there are these drivers, and we have got to find a way to access them. So we need glad, or like we need a OpenGL function loader that is going to give us pointers to the functions in the driver. So the pointers will let us use the OpenGL driver, and there are different ways that they're exposed. So glad is one way it's exposed. There's also, I don't really know any other function loaders, to be honest. I just mainly use glad. So we look for glad here. We want to generate version 3.3. Generate loader. Right. Just put this over here. So yeah, we're going to extract it, and then we're going to grab the include and source files, and we're going to create a new directory in our folder, call it external. Then inside external, we will have glad, and then glad will have an include directory. It will also have a source directory, and we're going to use cmake to tell it. So we're going to tell cmake that we have now got glad in this directory, so that it knows where to find the source, so that we can add it, we can link with it, and where the include files are, so that compiler also knows, and we're going to do that through cmake. So to do this, we have to use a variable. It's called cmake source something. Let's go on the cmake specification. Cmake. If I just remember the name, I'll be able to find it. Cmake source directory. Cmake source. It's a variable here that specifies the level to the current cmake source tree, which is this level here you see. So we can access the variable by doing $ like this, and then specifying cmake source dir like this. So this lets us access this variable, the value of it. And so what we're going to have to do is we're going to have to target, first of all, let's target the include directory. So I believe we write target include directories. Specify the target. We want the main target, and then we want, where are the directories? Well, they are in external glad include, and then that's where the so on and so forth the header is. So we'll create a variable, and we'll call it glad directory. So this will be this glad directory, and we'll set it to the value, which is cmake source underscore dir slash external, because that takes us to that root level glad, and then we'll leave it there. So then in here, when we target glad, target the include directories, we also need to specify whether we want the include directories to propagate to any other targets which link with our main target. We'll set it as public, the interface, if we want that to happen, but we don't want that to happen. So we'll say that it's just private, and we then will specify where is the include directory. It's in glad the glad directory. This is our variable. We will need to access the value of the variable, so we encapsulate it like that, and then include, just like that. So this is including the glad include directory, so that our compiler will know where it is. This will let us do things in our main function, like writing include glad slash glad.h, because if we go and look at external include glad, this is where we set for the compiler to look. We see that we have glad and glad.h, and if we then we might have to regenerate the build files. Cannot find source file main.cpp. Let's just take a look at our cmake. So we're targeting include directories, adding executable, cmake error, add executable cannot find. Okay, so for some reason, we've moved main.cpp into source. So let's just fix that there. Okay, so we'll regenerate the build files like this. Okay, great. And yeah, you can see that there was no compiler error regarding the finding include file, that include header that we just added here, right? Because we had actually just told where the compiler was. We told the compiler where the include files were. We're glad. Right, so this is now glad basically set up, so we get to access glad, but now we just need the source file so that we can add the source file to main for it to link with. So we will literally just going to add the source into here in where we specify add executable. So I'm going to set the variable a little bit earlier, and then I'm going to instead of source main.cpp, we need to also add glad, which we will add soon in glad directory slash glad, and then it goes source glad.c. We just need to, yeah, there it is. And now the source file is there. We're telling the compiler, okay, we want you to link with this glad.c file. And that is basically the setup for the function pointer loaders. We still have some functions that we had to call inside main, which we'll do soon. But yeah, so that's basically that setup for now. And the next dependency that we need is going to be glfw. Now, just to demonstrate, I will show you that if we try to include our glfw headers like this, we're going to get an error because we have not added the file yet. So we need to set it up with cmake. The way we're going to do this is by going on glfw's git repo. Here it is, and we're going to not use get submodules. We're going to actually use something called fetch content in cmake. So we'll include fetch content. Then we want to do something called fetch content declare, which will let us declare something which we want it to fetch to integrate into our build. So we'll set the name first, just to glfw. We'll set the git repository to this link here, which you just simply copy, and then we'll set the tag to a tag here. We'll set 3.4. Now, once you have declared all of the third-party dependencies that you want, then you can just make available. So that will, this is the thing which will, declaring doesn't really actually do anything, but pulls in metadata. Fetch content called make available is actually the thing which is going to go ahead and fetch from that repository all the source. It will access the cmake lists.txt, it will build the source, and then it will put it into a special thing that I will show you inside this build file. So fetch content make available, and then we're going to specify using the same name that we gave it here, glfw. Then finally, we don't need to, I don't think we, I'm not sure if it links for us. So let's test that and find out. So you can see here now we've got this extra folder which just literally just spawned in, called _deps, and you can see here we're getting this error here. So we've got this build, the source, which you can see is the exact same here. So this is the source which is cloned and all that stuff. Yeah. So now that we've made available, we have to link with it. So let's go ahead and link with it. So we're going to presume that it's a library, and I think we do target link libraries and then main and specify the interface with private and then glfw. Let's run that, see if we get an error. If we get an error, then I know that that's not the correct syntax. Okay, no, so look, so now that we've linked with glfw, Opengl already had it already included, glad already provides. Now this is only an issue. We're getting an issue here that we've already included the Opengl header. And this is where the issue is coming from, because of a header guard and compiler error 1899. Oops. You can see we're getting error due to macro inside glad, I think. So let's try and fix this. And I think the fix is to it's actually kind of a little bit confusing. Let's try link before we include, you know, so that wouldn't fix it. I'm just gonna run from the top to see if we can just try and fix this quick. Got the minimum required version. We're setting the project. This is a variable. Here we're setting the source. We've already specified where the source is. Fetch content, then declare this, make it available, and then I'm linking against it. This, I know that the error will be resolved if we just comment out glad. So, the error comes when we are including glfw before glad. So then this will now be fixed, and we have now got access. This is the basic setup, in case anyone was actually watching and wanted to know. This is the basic setup that you need to have a minimum working OpenGL thing. So now is all we need to do is just go ahead and set it up. So we actually need to start now with the OpenGL stuff. I will just show you how to do this with glfw. So, but first of all, why don't we do something extra? So there's a C++ logging library called spdlog. You can see that it's got, this is how you use it. So we'll actually also pull this in as a dependency, so that we can write logs like this, which is pretty cool. So if it's got cmake lists, we know that we can use fetch content. So we will declare in cmake lists, not glfw, but we'll call this spdlog, set the git repository to something else. Here we go, this one. Let's go here, paste this. Then the git tag, we've got this. We'll just take the latest version, which is 3.1.16.1. Right, now we need to add it here in this list, spdlog. I also want, and I want to link privately with spdlog as well. This should now include, let us include spdlog into our thing. Let's just take a look at how we include it. It should give us an example. So there you go. So this is how we include it. So spdlog, just like this. Now, if we compile, no errors. I'm just regenerating the build files, and it should be fine. Sure, it's taking a while. Then let's build. So yeah, you can see SPD log is now being added. If you take a look at build dependencies, you will see here SPD log source, where this is once again, I've already said this before, but is the exact same as this. And then it's going to use their cmake file to configure, and then we're linking with the source there. Now to test that is working, let's just go ahead and call one of these functions. And it should, where's my, yeah, so there you go. So now you can see we've got the date, the time, and what type of error message, if it's info or whatever. There's just a very easy way to get out of that basic console logging, make it a bit more descriptive, I suppose. So now let's, why don't we create a source file? I'm just thinking. So instead, let's go through the basic GLFW stuff. So we'll start by initializing GLFW. That's how you do it. It has a return value that we will check if it's negated, the return value, because it returns 0 if an error occurs. Then we can log an error that GLFW did not initialize, and we can return from our main function with a code of -1, something like this. Okay. And for the sake of like logging, we'll just log with info if we are successful. Successfully initialized. Now we will see if we are successful that we have initialized GLFW when I run the source, run the executable. Okay, so yeah, it was successful. So that's how we know that GLFW has successfully initialized. Next thing up is we will create a window. This is where we start to get interesting with all the graphic stuff. So we'll create a GLFW window star, which is basically a pointer to a window. And we set the return value of this function. Now this function takes in 5 different parameters. So first 3 are your width, your height, then the name. So if I want a frame buffer of if I want the frame buffer, a default frame buffer, because it's the window is the setting up the default frame buffer. It's going to have an array of pixels where you've got different attachments like color buffer, depth buffer, and every draw call that we do is going to be initially, unless we change it, drawing to this default frame buffer which the window is actually creating for us. So we will set the width, height, and name, and we might as well do this with some static variables. So let's just go ahead and do this. I don't really know if I like this way of doing, but it's fine. It's kind of like C style, isn't it? We're going to need another dependency. Not necessarily. We could do a constcast star, but we're going to have to include a string. So string. We'll call it window title. And let's change it to static. Why not? Internal link. Let's just call it fixed window. There you go. So now I don't want static. It doesn't really matter, but I want const instead. Just a bit of a brain problem there. We'll call it with our width. our height, our window title, and we call it with the C underscore string, which will return a C star string. This glfw create window function is expecting the name to be type const star. This was probably just an integer type. In type, and then if we take a look at the spec just for the sake of it, we can see that in the specification it wants a monitor or whether it's being shared. So for the monitor, I believe I will just put null, and I think I'll also just put null there as well. So this will create a points to our window. Great. All right, next up we will just check if we created the function, created that. This will be if window for a pointer, so we'll return true if the pointer is non-null, right? So we're going to negate that, because if it's null, we want to run this. We will also then error that the window was not created. Without a window, there's no point sticking around, so we'll just return. Otherwise, we can just come up here, copy this, paste this, copy that, paste this down here, splog, and then we'll just go ahead and say that we have not successfully initialized GFW, but successfully created window. Right, let's go ahead and rerun our code after doing that. As you can see, we got a little pop-up, we got the info, the successfully created window. All right, nice. So we're creating a nice log here that just shows us what's going on. Now, the next thing to do before we load in our OpenGL functions is to make the context current. So this is going to basically say it's going to. So there's a thing called the OpenGL context, which is basically the state of OpenGL, and you can make different windows be the current context, which will effectively say that all the information associated with OpenGL state from this window will be the one which is used in subsequent OpenGL calls. And it also so happens that you have to set the current context before loading in the functions, and I think that's, I'm not entirely sure why that fact is. So we'd call GFW make context current with the window, and then I don't actually know if there's a return value, which is actually an interesting one to know. So let's look up that function. It's a void return, so there is no return value. So, but we'll still info that window, and we'll just use the window's name. So window named, and we need to look at this. Okay, so you use here we go. So you use these brackets, and then you put what you want to be there later. So I think it's like so we'll want the name, so we'll just do window, although that's a C string as well, has been made current context. Okay, let's rerun and just see if I got that right. Okay, window named graphics window has been made current context. So we're building up a trace here where we can tell what the actions that we're doing are. Next, after making the context current, after we made the context current, we can load in glad, and we load in our function pointers. This will let us use functions like glclear, glgenbuffers, all this stuff. These calls won't work unless we load them in using a loading library, but you can also load them in yourself. it is just more verbose to do so. So people tend to use a library to handle that aspect for them. So just make sure that we've included glad, which we have. So then we will call this function glad load gl loader, and you want to typecast it to this type here, glad load proc, and then we will get the Windows current address. So glw get proc address like this. This should load in the functions, and if we take a look at the return value of that function, we can see that we're returning an int, aren't we? So the status is initially 0, and you can see it says if OpenGL this, right? So if we can kind of infer that this is going to run if we run. So we're going to return 0 if we don't have OpenGL, or if OpenGL. OpenGL is probably just a function which checks if OpenGL is installed on the system, if there's an OpenGL driver. Yeah, look, it says load library OpenGL L32 DLL. Right, so let's go back to this. So status is 0, right? So we're going to be returning 0 if we fail. So we want to negate that if we want it to trigger on error. So we've got this. Then we'll give an error. We can't use OpenGL without our function, so this is a critical error. So let's just go ahead and log this as error starting. Error loading open function pointers. This is all just kind of like basic loading up stuff. I haven't really gone into any graphic stuff yet. That'll be happening quite soon. Otherwise, I kind of just want to do an info log. We don't really need to do an else. We can just do it here because the if would have ran before. Otherwise, we can just say OpenGL function pointers loaded unsuccessfully. Right, so we should just see that OpenGL function pointers loaded in successfully when we run this, and we do. Now we basically have access to the GL functions, we have access to our window, we can now use OpenGL calls, we can basically done all the very basic setup. So to keep the window open, we basically have to loop it. So we're going to use a while loop, and we're going to check that every single time the window is window flag is open. I'll just show you here. So GFW window should close. I believe it returns a boolean. There you go. So here, so returning an int value of the close flag, which is attached to that window object, right? So here, so while not window dot should. Nope, that's, I'm so used to writing my own classes that I just did that. While not glfw window should close like this. We can do some basic stuff. So this is just going to keep the window open. So let's not clear any buffers. Let's keep it simple. First of all, we're just going to, we'll just call glw poll events. This is going to poll for any key presses, any updates, which is not really that relevant right now, except for when you click the red X button, you're basically going to be changing the flag. We need to poll for that event. I'll, for the sake of it, just show you what happens when we do not do that. And we also need to swap the front and back buffers. Basically, the way it works is that we're always drawing to this back buffer with our draw calls, and then we swap on every frame. So yeah. Next up, we've got some cleanup to do. So we need to destroy the window and then destroy this. So, you know, just destroy our resources, right? So let's take a look at how we destroy a window. I believe it's glf to destroy a window. So you can see it's going to, yeah, I destroyed with glfw window. Let's go to the next. When a window is no longer need to destroy it. All right, so let's go ahead and do that. So we'll just call it on the outside for now. This can be encapsulated into its own window class later. And then we also We also then need to destroy, sorry, not destroy, because we called GLW init, we now need to de-init, you know? There you go, GLW terminate, I just saw it there on the window. So let's go ahead and do that. And then we can couple these with a info. Actually, is there like a kind of like a warning? Let's take a look at SP log. Yeah, so we got warn. Warn would be better for destroying a window. Now, there's probably like a unique window ID that we could use to do it, or we could put the window name. You wouldn't want to put the window name. Create hash function to create a unique ID for a window, but kind of a bit more complicated and not really necessary. So why don't we just come here and grab this, come down here, change this to warn. Window name this has been, go forwards a bit, and then just say destroyed. And then we'll just warn that. GLW has been terminated. Okay. Now we have got a window open. Here's our window. We're not clearing any buffers, so it is black. But yeah, without poll events, we wouldn't really be able to close it like that. I'll just demonstrate that because we need to be polling for the events to update any changes. Yes, we could just got this circular loading thing. But we can go here, press Ctrl C to do that. All right. You can also see that that didn't run because we just exited early. But if we normally close, we should. I did not recompile. That's what's going on. All right. You can see that then we get these warnings. Window name graphics window has been destroyed. GLSW has been terminated. Okay. Right. Next up, let's get some color on our window. And then let's draw a triangle. So let's go ahead and clear our buffer bit. Now this is interesting. Let's GL color buffer bit is basically the color buffer has a, it's a really good question. I don't think I've actually asked that question before. Because usually we can clear the color. We need to call that to reset it to its default value. And then we clear the color with an RGB value, right? Like this. But this isn't, is more like an RGBA value. And you'll see that if I can recompile and then run, that we get a color by doing GL clearing this to default value and then clearing the color. But let's take a look at the GL buffer bit. So let's pull up our specification for OpenGL. And let's look for GL color. If you remember, it's not like that. It's like color buffer bit. I wonder if this will come up. Okay, there we go. So we have got clearing the buffers, setting portions of vary for things. So then you can see, so we've got the bit field. And the values are color buffer bit, depth buffer bit, and stencil. So you can clear all these values, and these are indicating the buffers enabled for the currently enabled ones. So here we go. So the values which each buffer is cleared depends on the setting of the clear value for that buffer. If this is 0, no buffer is cleared. If it's bits. If buffer contains, okay, so here we go. So now this is going to set the clear value, right? Which is going to then update these. There. Yeah, but it's really just setting the color of every in the color buffer, which is like a a 2D array of just colors per pixel to this value everywhere. So I just want to take a look at the color, see if I like the color. Yeah, I'll do. I'll make it one step demo. All right, next up, I just want to check if this on the stream it is clear. Yeah, that's clear enough. Okay. I just need to go back. Okay, there you go. Right, so that's all done now. So why don't we just quickly write some comments just to specify what's what. So we'll be doing the OpenGL setup here. No, this is OpenGL specific. And this is OpenGL setup. Okay, great. Now then, so OpenGL specific. Let's just get right into it. So here's what we're going to do. We will create a way to write shaders, compile them, link it with the shaders with our program. We'll be reading in the shaders from a certain directory that we create in a source, not in a source. We'll just create a directory here, shaders, and we'll be using that to load in our shaders and stuff. So yeah, why don't we start with how the whole OpenGL thing works, right? So let me just take you here. So OpenGL has got, this is really just a description, but we've basically got this. You think of this as the context. You've got all these things, right? Whatever. We've got like all these different settings in the context. You can generate something, and when you bind something to the context, so bind, then it's going to, once you bind, it's going to update this value that the context is holding so that it knows what it's binding. For example, if you are binding a GL array buffer, this will assume that this is the GL array buffer container in the context. It updates it with the new value of that you assigned when you bound it, which is really just an integer handle for that case. I'll just show you soon. Go back first though. All right, so coming back to this. So the first thing that we're going to do is generate a buffer. We'll just do the basic setup. So we'll call it the VBO. We're going to generate how many buffers? One. Where do we want to put the names? This isn't actually a array. It's expecting like a pointer to a possible array. Because if you want to generate more than one buffer, obviously then you'll need a container which isn't just one variable. So we'll just put it here into this thing. Then we can bind, like in that mental model that I spoke about, to the GL array buffer target. What do we want to bind? We want to bind the handle generated by OpenGL, which is called, is now stored in VBO. Array buffer is just a buffer of data. We haven't really uploaded any data yet, but it is to be just a one-dimensional array of data. That's it. And it will have a certain type of data that will change the size, but that's really just it. So to upload data to the server for the sake of speaking is just the OpenGL's like side of things. Could be on the GPU. If it's a software renderer, it'll be on the CPU side. I like to use vectors because they are not as like finicky as pure C-style arrays. But let's create a standard vector of floats called container, called triangle data. That's much better. Okay, now we need to specify the vertices. So the way this is going to work is a vertex. Okay, so here, let's go back here. A vertex, consider this to be a vertex. Vertex is really just some abstract object. It has attributes, vertex attributes, right? It has a position, it might have a color, it might have things called normal coordinate, normal coordinates. Saying that right. Texture coordinates. It might have like a bunch of these different attributes. And the one that we're going to set now is the position attribute. These lie, if we want this data to be seen, we have to specify them initially. In the range -1 to 1, right? But this mapping of -1 to 1 should actually happen by the projection matrix, which we will go into later when we set up the camera, because this is about creating Minecraft, which is the 3D world, not just 2D. But it's actually just nice to draw a triangle first. We also will implement the camera from scratch. I might get tired, but we will just try to implement it without using GLM, just for the sake of the maths. It might be a little bit tricky, but just give it a try anyway. Okay, so this is the X coordinate. This is the Y coordinate. Then this is the Z coordinate. I just set the Z for 1.0, but let's just do this and then that, and then we want this to be minus because it's going to be the other side. It's going to be like this if we just draw a triangle. This is the first set of 3, this is the second, this is the third. The Y would stay the same, but I don't like that. Let's set it to -0.05. Okay, and then this should be in between if we want it to be nice and even. 0. Okay, this will do. Alright, now let's look at how to upload that data that we've literally just defined to the server, or to the OpenGL server. Well, we call this function, it's called gl buffer data. And we need a target. What is the target that we're sending the data to? Well, the target in the OpenGL context that we've bound is currently the ID VBO, which is some integer. It's got this target, and we want to say, okay, we bound the target. Now let me upload the data for the target. So I want to use the currently bound one. When I'm writing GL array buffer, I'm basically saying use the ID bound to this target. So upload the data to the ID under this ID. And if you look at the open source implementation, I think it does actually have like this hash map for these IDs to the data, or to the metadata of the VBO. That is not a claim. That is probably entirely wrong. But yeah, upload to there. If you think about when you need to upload data, what do you need to upload? Well, we need to just tell it where the data is, and we need to tell it the size of the data. So those are just the basic things. So what is the size of the data? Well, we can call triangle data.size to get the number of elements in that array. And then we know that we're dealing with floats, right? So we'll just times by the size of float, which will give us the size of the float type, which should return 4 bytes. This is 1 bytes. Next, we can do this. This is me, when I call the data function, I'm specifying a pointer to that data. And then this is the one thing which kind of doesn't necessarily make sense the first time you see it, which is the drawing method. Static draw is going to be the way that we do it, because we do not need to change the data. If we were changing the data, re-uploading it to the same buffer location, then we wouldn't want to use static. The static is when you upload it once and you read it many times, I think. Let's just take a look. You can see here in the spec. So static draw, then it'll have the usage, the data store contents specified once, used many times for drawing. Cool. Now the data is up there now. It's done. All right. We don't have to think about that. So to access it though, we will have to think. We will need to get a VAO. We will have to generate a VAO by calling a gen function. We'll bind it's not a buffer, it's kind of like a wrapper with a bunch of pointers that specify how to access the data in a buffer. So we will then bind vertex, list of vertex array to the geo context. So this just takes on like a target. There is no target because there's only one target we want, and that's the VAO target. So that's really it. So then we can specify the data. So we do this by calling this function geo vertex attribute pointer, which is this is just going to be how we navigate that data which we're going to upload. Now I want from this thing, I will first specify a location, which is like a code that the shader uses to match the layout that we're defining with the data that we'll soon be using in the VAO, in the shader, which will be 0 for now. I don't really know if I remember this stuff, because this is a little bit specific. Yes, so next is the size of the components. Now our position data has 3 components, so we can just put 3 there. Yeah, I don't really remember much else. Let's just take a look. Should be the function. I just want the function. Don't know why it's taking hard. Vertex attribute pointer. It's not hyperlinked. Oh, here it is. Oops, it's the first one. Right, so as you can see, we need the index, the size, 3, the type of the data, right, because it needs to know what is the size of the data when striving, whether it's normalized, which is whether or not it will be converted to a specific range. Doesn't need to do a conversion. That wasn't a very good explanation. It is kind of like details that we don't need to know, but yeah. If it's an integer, it's only really if it's an integer. It doesn't need to be converted to a float. If yes, then set true and converted directly to floating. No. Data for an array will be specified. Converted to floating point by normalizing if normalized is true. We don't need this, so we set it to false. Let's take a look at what was the next one. Oh, false. I literally just wrote false like that. Next is a stride, which is the size in bytes between adjacent... No, not between adjacent. Yes, between adjacent attributes, which are the same. For example, you have position color, and you need to say, okay, what is the distance in bytes from our first position to the second position? Now here, you see we have 3 different floats, so this will be 3 bytes, right? So we'll do 3 times size of float. Finally is a pointer, which represents an offset. Just for the sake of it, we'll typecast 0 to void pointer, but it's just the number of bytes of the current attribute that we're specifying into that buffer layout. For example, here, because we only have 1 attribute, it's 0. But if we had 2, the offset might be 3. You know, how many bytes do we have to go into the buffer starting from the beginning to access say, the color data or the texture data. And then finally, you actually have to enable this. You do this by GL enable vertex attribute array. Give it the thing. You can also do the disable. This will actually enable it to be read in by the shader, just so it's active and we have access to that. And that's basically setting up the VO. That's setting up the VBO. So we've now uploaded the data and we've told OpenGL how we want to read the data, which is just the two basic things. What is next? Well, this is all the data side stuff, which is good. So now we've done all the data side stuff. We can sort of now go, okay, so we've created location 0. We've enabled it at 0. Okay, let's create a new shader, right? So let's go ahead and create a new shader. So we'll just start off, we'll call it triangle vertex. Now every shader starts off with this, it's the preprocessor macro. No, not macro. We're just telling it metadata. What is the version of the shader we're using? Version 330. But it is a preprocessor because it starts with a hashtag. So we're writing currently in GLSL, and this gets compiled, I believe, to intermediate form called spurv, I think. But yeah, the function goes like this. They also have it is void, yeah, void main. Kind of just like in the C++ programs, the entry point. Now to access that data from our vertex attribute array, you have to use layout location like this. We have to say, okay, so what are we doing? We're taking in the data. What is the type of the data? It's a vector3 type. And what data is it? This is the variable name now, so we'll just call it like a position. It's a position. Okay, and now there is this variable in GLSL called gl_position, which is like this default thing which is written to. It's kind of like the default thing, default vertex position, which is defined by OpenGL, I believe. If we can't find GL position in this specification, what we can do is pull up the GLSL specification. I'll show. So you can see it's not really on GL position. Yeah, the built-in special variable GL position is intended to hold homogeneous vertex position. Homogeneous coordinates is like another thing that we can get in when we go into the maths of 3D graphics. Anyway, this is all we really need for a basic vertex shader. Next, we will be sending this out into a fragment shader. So let's go ahead and create that. Again, we're using the version 3.3. We also want void main. This time we are writing not to GL position, but this. No, that's not what we want. We want to define ourselves a variable to send out of this shader stage. So out spec 4, and then this fragment is responsible for sending out the color. Now we'll just set the frag color to some default vector 4. Let's say we want our triangle to be gray. With this is just an RGB value, so yeah. Okay, now let's come over here, and we've defined our shaders. Now all that we do is we just read it in from our files that we created ourselves, and compile the shaders. We really should be reading it, like logging some of this stuff, but let's not log it for now, just because we're writing. So let's read in this data. I'm gonna need this include. I don't know if it's string or string. I think it's string. No, it's not string, it's ss stream. like this. Okay. Now I will just take a little break and like just write this out myself, because explaining everything is kind of long to do. We also need another include called fstring. This will let us access the files. Now, as for the path, we know it's like this because we're running our cmake file from the source directory. Okay, I think I'm back. I dropped there for a bit, just my Wi-Fi acting up a bit. Okay, yeah, we're good now. It's good that the stream didn't cut out. Yeah, so basically here we've created a string buffer. We've created 2 in files. You should ideally check if these files are open and so on and so forth, but because I will probably be encapsulating this stuff into its own class, we can just ignore that for now. So here's the file. Now these have a method on them. These classes have method on them called read buffer. We want that because we can basically read into the buffer that's contained by the folder, and then I will just demonstrate. If we then call the .str file after reading into the buffer this, we should see the vertex shader appear in the text. GLBind buffers. That's wrong because we want GLBind buffer. You can see there we're reading in the vertex shader. Okay. So instead of couting it, we're going to store it in a const cast star. We'll call it vertex source C star. Oh my goodness. This whole time I actually have not really been committing much, but that's just because equals. Yeah, that's fine. It just feels a bit weird to do it like that. I think that works. I don't know if there might be an implicit typecast. Yeah. So there's a problem here trying to typecast from buffer.string to const in one step. Right. So this is actually going to be a little bit irritating. Actually, why don't we try and call a cast on it like this instead of doing that other stuff that I was just about to do. I don't even know if that is possible. Yeah, no, let's do it the other way then, huh? Actually, let's check out just this quickly. Just because there's no one here, I might as well. So static cast target, experience. Yeah, I will just first read it into a string. Then let's take that string and call the cstring method on it. Now we've got the vertex source cstyle in a string, which isn't actually necessary because when attaching source, you do something like this. You first create the shader. I'm not sure if it's like this actually. This is interesting. If we get an error here, I know it's the other way. Okay, this is fine. Actually, yeah, this is fine. So then, I just want to actually check that. I'm going on this. GL. Oh, no GL, remember. Okay, so create shader, yeah, return unsigned int. Good stuff. So you create the shader and then you need to attach source to it, which you do by GL shader source. Which one do we want? So you can see in this, you got a couple. First is the shader handle, the count, which is the number of shaders you're attaching, I think. An array of count pointers to null terminated character strings that make up the source. Yeah, so it doesn't actually make sense what I just said. The number of numbers, because you can only really attach one shader to a shader object, I think. Never heard of anything else apart from that. So what it's actually doing is if you've got an array of null terminated strings, which are making up that one shader, then how many strings do you have? Put that in the second argument. Okay, so now we need a pointer to the pointer and length, which we can put as null because we are not using it. So that second and third argument are really just if you are using those count things, I think. So the length argument is an array with the number of chars in each string. So yeah, we just don't need an array with the number of. You can tell it's using that to basically you've got the buffer and then it's pulling out how many bytes it needs from the buffer from each. So that's why. So the second and fourth argument in this are only if you're using an array of C-star strings. So now that we have sourced the shader, why don't we go and compile the shader? And I believe it is just GL compile shader. Take away the GL. Yeah. Okay, and now we need to replicate that because we're not currently creating our own class because I just think it would take a bit too long right now. I just want to get set up. So let's read in the fragment file. And we're going to have to reset the buffer. We can actually do this by calling the string method with something inside it. So we'll set it the buffer's contents to an empty string. And then we'll read in the fragment file here. Then instead of vertex string, we'll call this fragment string. Instead of vertex source C style, we call this fragment source C style. Instead of vertex shader, we'll call this fragment shader. This is where you can make a lot of errors. Instead of creating a vertex shader, we'll create a fragment shader. Then we need to change these as well. Now let's compile that. Finally, we just need to create a program. Now this actually takes no arguments. Then you need to attach your source to the thing, which I think is GL attach source. You can tell if I scroll down a bit, I'll find it. No, attach shader. So let's attach shader. First argument program, second argument the shader. Then you compile, you link the program, you don't need to compile it. Program. Right. That is basic shader setup. Let me just check for any errors. Alright, seems like we're good. Now, after all that, we can finally draw a triangle. And, you'll believe it, with all the talking, it only took 65 minutes. So, let's do that. So, before drawing, and not before clearing the contents of the screen, let's just find the vertex array. Then let's use the program that we want. So we bind the vertex array, we're using the program. Now we can go ahead and do a draw call. So this is the primitive type which we want, I'm using the triangle primitive. It will take sets of 3 vertexes for each triangle. This middle argument is the starting from the buffer we're taking from. Which vertex do we want to start from? Vertex 0 in that buffer. How many vertexes do we want to take from that buffer? I want to take 3 because I've only got 3. And if I go and hit build and then run my program, we've got a triangle. Nice. Good stuff. Now, a little interesting thing which is going on here. If you'll see, that triangle was white. Right. But here I'm not specifying white, I'm specifying gray, right? So that's a problem. And the problem is probably coming from the way that we're compiling the shader. So let's go ahead and take a look. So just checking that this is all right. We've got an outvec for frag color and we're sending out. So yeah, the shader is fine. We might end up having to read the error log of the shader, because if there is an error log and it would say what's wrong. But I believe I can fix it. Here, it's here. Here we're calling vertex string. Let's call fragment string. There you go. But no, not like that. I don't know what the color is, so whatever more, yeah, that's the color. So there you go, so fix that one. Oh, got a triangle. Right, next up, I'm just thinking, what should we do? So we're obviously going to need to render a cube. So I think we can start working on the camera now, because the camera is the most important thing. Now for the camera, I will actually be creating a new class. So let's write a camera class. Now I actually don't really enjoy this part that much. It's very tempting to just use GLM, but I did say that I'd do it by scratch, and that's part of it, isn't it? So we'll just write the camera class. I will not be writing it in the same as main. So now is when we will do all of this extracting out into our different source files. Okay. Now let's just do this pragma once so that we don't get any include issues with redefining the class. Class camera. Okay. So let's come to our drawing board. Take a look at what a camera needs. So here is the axis of our world. Opengl is a 3-dimensional graphics API. So we have 3 axes. Like this. The camera is an object in the world that will look like that. And from this camera, there are some features. This is called the near plane. Then that's not the near plane. That's the distance to the near plane. This is the actual plane itself, where different things undergo. I think it's first easier before straight away looking at this, just covering some basic things to do with like moving the camera. No, scaling objects. Okay, so in Opengl, you've basically got all these vertices, and the vertices are coming into the shader, and then they're going out of the shader, right? Now, this might be one at a time, but this might be all at once, and you know, it doesn't really matter to us right now which one the case is. Either way, all of the vertices are being transformed, and that's the point. Now, if you transform all the vertices each the same way, say I have something in the code which says vertex position plus equals 0.2f, then we know the vertex shader runs for each, so all of them will be transformed 0.2f to the right, and this will end up going like this, right? So this is the transformation. So it's like a transform on all of the vertices, which results in the transformation of an object, right? Scaling works similarly. If we consider the origin of each of these positions, because each position is really a vector, then we scale down and we look at the length of these vectors. So imagine if you times a vector by 0.5f, then each of those arrows will get shorter, which has the effect of scaling all of these down and doing this. And then rotation's a little different. Rotation has got a derivation, which I'm not entirely sure I want to really go into right now, but it's not the hardest one, but at least in 2D. It's in 2D. So you load in objects, and then you do the transform on them. And then you do, that's called the model transform, and then you do something called the view transform, which is related to the camera. Now, the camera has a position in the world, somewhere in your 3D world. And it also has an orientation, which is basically, you can think of an orientation as which way are these vectors which are coming out of the camera object pointing to. So in our 3D world, a camera will have a local axis, maybe, let's say, describe it like that, where it could be rotated like this. And I mean, this goes for any object, right? Could be rotated like this. And you can see that this vector here, which is coming from the top of the camera, is changing. And it's got 3 such vectors, one for each sort of direction, so that it has a 3-component. I was just thinking about how to say this. It's got a position, it's got the vectors. It's like it's a local coordinate system, right? So you can sort of imagine the coordinate system changing. Let me pull an example. So it's kind of like this. Assume this is a camera. This is actually called a view frustum. I just stuck it together. It can be like this, and there are like different vectors pointing out, right? But if you imagine it as a sort of, there's a cube here, which comes here, and then it has one pointing towards you, one going up, and then one going out. All of these vectors are perpendicular, which means that I believe the official term is something like an orthonormal basis. I will pull this up. So yeah. So this is the linear algebra definition, but unit vectors which are all orthogonal to each other. So once those vectors on the camera are normalized, then they will form an orthonormal basis. And because of that, we can I believe we can just kind of like do the inverse of it, but it's not happening to the camera. The inverse isn't happening to the camera. The inverse is happening to all the objects in the world. So when the camera rotates, say, maybe if I just start writing something, it'll be a bit more obvious. So, oh man, because I chose to do it like this, let's write our own little math thing. So write to vector 3. Three floats. Actually, if I just define this in a header file, then I can just include it. Then you'll get like redefinition. Yeah, let's do it like that. Just because I want to just be able to include it. Now this is maybe not the best way to do it, but I know that GLM is a header only library. So a vector has got an X, Y, and Z position. The camera's position will be of this type. So we'll include this. This is in. I want to. Let's move this to the include. Right, like this. Okay, so this is of my type vector 3 position. Okay, now let's include from my include in this source file. This is honestly going to take a while. Oh man, let me just check. Okay. So, okay. Basically what I'm going to do is I'm going to flesh out some stuff with the camera. So the camera's got a position. It's got a vector which points out the top. It's got a vector which points out to the right or left. Doesn't matter. Point is cross product in that case. And it's got one which is front. So let's do vector 3 for the position. Front. Top. Right. So these are the thing, right? These are the basic ones. Now, we're going to want a constructor where we default initialize all of those, right? And a constructor, there is no return type. so. Now I'm not defining it just so that I can move a bit quicker. I'm not sure why I did an H. Should be HPP. Okay, now, so we're going to read in the position. Hop. Right. Right, now as for that, we can now initialize these. So I want to just differentiate for the sake of it, because I don't like writing the same variable in the include list. So I want the position in, top to be top in, the right to be right in, left to be left in, like that. This is just a quick test so that I know it's being called. Okay. Now, for the sake of it, we'll come here and we will include our camera. And now let's just create a camera. We're going to do it at the bottom of where we've just done all that boilerplate stuff. Camera, cam. And we're going to need some default values. Now, can I have to pass in our vectors? Now I see, you know, like I can understand why using GLM is nice here, but there is some merit to writing it yourself. Also because I want to try use as little dependencies as possible. Just for the sake of this stream, really. Standard? No. I've not defined a constructor for our vector. I mean, it will be fun to see our maths running in this world. So yeah, I just set up very basic. Now we need to do some top left. Wow, that is bad actually, now that I think about it, because specifying these in the constructor, I don't really like that. So I'm going to just specify top, define these in the body and leave them undefined till that's done, because otherwise the overhead in the file itself is actually not that great. So let's then just do top equals with X, Y, and Z, but all of this will be 0, right? Okay, and then we'll do this for right and up. Just make sure now the cameras cannot open include file. Okay, this is because the include directory is wrong in source main. Seems like that does not do it, because actually it's telling me something. Because we need to navigate from main itself. I don't really like doing it like this, so I kind of tempted to include it in cmake, but we'll leave it like that for now. Okay, I thought that'd fix it. It says vector3.h, but I've got HPP, which is good. And this is in camera. It's just I forgot to update this. Okay, now I've got some missing semicolon somewhere. Which file? Main line 98. Yeah. Forgot to write it. Okay, another one. Line 32. What is this? Actually, this is so weird that we're getting an error now for this, huh? Cannot convert from const camera to int. I'm not passing in a camera here. It's in main line 32. Main line 32. Whoa, what is going on? Cannot const camera. Have I got const camera? Oh my god. There's no semicolon. That's crazy. There's no semicolon at the end of this file, right? So the class is not finishing, which means that this is being replaced here with the camera. Right, really weird bug there. Really weird. Right, prototype function was not called. Let's just ignore for now. Okay, and let's just check that. Seems like we're not getting logging for the camera because the constructor is not being called here. For the camera position, start off with just all zeros as well. Seems like I haven't defined the constructor correctly because I've still got it 4 here when it should just be 1. Okay, I haven't added it to my cmake. And my source. Oop. So close. Okay, I've not got the right include in which file? Camera.cpp. Oh, lots of errors going on. Of course, this isn't right. Up with an oh, goodness me. Those should be member variables. Yeah, but there is no up one there. But there's top. I called it top instead of up. What do I prefer? I prefer up. Next, we've got no appropriate default constructor in vector3.hp 3. This is like a debugging, just constant CR declaration. This is technically a declaration. shouldn't be writing this in the header file if I've got an implementation file, but I don't, so it's fine. Yeah, what's the problem here? So so in camera.cpp, line 5, 65, taking a position. Okay, so here I'm taking in a vector 3 and then trying to do with floats when I need to sort of define one which takes in a vector 3 itself and then extracts those members. Even more. Okay. Illegal copy constructor. First parameter must not be vector 3. Illegal copy constructor. Oh, of course, of course. Right. I have to it doesn't make sense. That's a good point. I wonder if I can just do that. Yeah, no, this is not solving it. Okay, so I'm going to read about this error because I have not come across this one before. Same type as the class for which it's defined. This ground can be referenced to the type, but not the type itself. Okay, so we need a reference. You need a reference, not... Yes, so... Why cannot be an identifier? So I want to know why that's the case. But anyway, let's just for now check that that fixed the problem. Okay, so it looks like it fixed the problem. Next we've got camera.cpp line 5, 61. Ah, right. Basically what's going on is the class is trying to default initialize all our member variables, but there is no default constructor for a vector type. So this here, what I was trying to do is just define them, but instead, why don't we just make the default constructor, set it so that they all start at the value of 0. And we'll do that just by coming here to do vector 3, and then we can actually just still do an initialize list like this, but just like that. Okay, that fixes it. Okay, now we are compiling. That only took so long, huh? Okay, good. Right, and... Okay. Right. So, now we've got the position, the front, and the up. The position, the front, the up, the right. Oh, we need to tie this to key presses. To change position, to change front, to change up, to change right. We also maybe need some functions that return matrices, the view matrix. And I want a couple more variables for the projection. But let's just stay here for now, like this. And for the sake of it, let's just check that that's working. Like, why is this not running? Oh, it is. It's over here. Yeah, I was just wondering, like, why is that not going? But it is going. Okay. Okay, there's no problem there. Okay, we kind of need our own matrix now. So now that we got the vector class, the camera class hooked up with the vector class, some of these probably should be private, but this is to worry about later. We can create a matrix. Now a matrix of 4. I wonder if I should call it 4x4, 4. To me, 4 is fine because it's a matrix. Actually, square. 4s for square. 4. Maybe just 4, 4. That kind of looks like 44, but to me, I think it's okay. And I'm the only one who will be using this for sure. So, to do that, we're going to need a vector 4. Let's just go ahead and copy this over, huh? And then just add one more component. Oh, we don't need to do that whole forward declaration. That was kind of just a pointless attempt at solving the problem real quick. Recompile, just make sure that doesn't break anything. Okay. Hey, check this out, check this out. Okay, so I can percentage s, so colon s percentage / vector 3 and now vector 4. Wait, percentage s / vector, there you go, look at that. Yeah. Well, I don't know why it didn't work here, probably because it's connected. Okay, so that's done. Now we just want one more component in this case, which is just the W component. So good. Okay, so now we've got a vector 4. I just named the fourth component W, just because it's kind of what they call it in for a homogeneous vector coordinate. And yeah. Now we can define a matrix. The matrix will hold a. We'll just use the C++ types. We can make a vector, a matrix. I'm thinking about how to access it, but we can always use operator overloading. Like, what are the key operations of a matrix? Apart from, like, say, transposing, how should we make it so that you can set it? I personally would like to be able to set a matrix by... I should probably put this in a namespace. We'll just set the matrix by creating it. Class. Right, matrix 4-4. So we want a 4x4. Now, depending on if it's row major or column major, it will depend on how we organize it. But for a default constructor, we will use a underlying buffer which has 16 different stuff in it, 16 positions for integers, and we will... Opengl once is so much easier than using like if-def, if-ndef. Yeah, we'll just use an underlying buffer of floats because actually we could make it a template class. Really could make it a template class. But I don't need template right now. I'm trying to make everything perfect. So we'll just call this a buffer. That'll be a member. Now here's the problem, you need to know the size if we are to do that. Make sure that there's no problems there. Also, hold on a second. How does it know about my math library if I'm getting here? Okay, so now we're going to want to create the library. Oh, because they're header files. I've defined everything in header files. That's how. Yeah, so that's not going to actually cause any problems until we include it. I need it to cause problems for me to know if there's any issues with it. Now that I think about it, I've just included the vector 4 and not the matrix. Okay, so it's fine. All right. Okay, so this matrix will have this underlying buffer that I'm tempted to use a vector for instead of just a raw buffer, but I don't know, it's maybe more simple to just use a C-style buffer. But we'll just go with that. Okay. In this, let's write a default constructor, learning from what I failed to do last time, where we initialize our buffer. Buffer dot. Thinking about vector functions. We should resize, reserve 16 elements. And buffer. I believe there's a way to fill out with default values without using like for loop explicitly. So how to default initialize vector with and values. Fill method. I don't really like using geeks for geeks, but it'll be fine for now. Fill with iterators. Wait, what? Where are they getting fill from? That could be like a heavy include. I don't like that. I'm just not going to do that. Here it is. I just want the exact, so it's an algorithm. Yeah, I didn't want, because standard bits, it includes everything, and we just don't need everything, do we? Then this thing we're going to reserve, and then we're going to fill with our iterators. So buffer.begin, buffer.end, and our default value 0.0f. Let's run it, and we're fine. let's try. And also, we will create matrix for 4 with a float pointed to a buffer where we will need to access each buffer at thing. So this is when we use for loop. Let's just make size. User has to type in a size as well. It's not the most flexible, but I think it will do. This is going to automatically, basically, I think it does this. It basically dereferences it. And then it adds iWorth to the address. Oh, she is it like this. Dereference. No, not like that. Like this. That's what it does. Just for the sake of showing. Oops. Equals. Oh, I've double named buffer here, so it's a little bit confusing. So I say buff. The add function for a vector will return this, no problem. This returns a reference, and I'm just overwriting the reference. Hey, it's not the most efficient, probably, but it'll do. And it will write from the beginning. B1. Anyways. It works. No problem. All of this stuff though is private because I am writing it in a class, and for some reason the others I wrote as a struct. Anyway, that's kind of just like the basic things that we need from a matrix. We actually don't really need to do it. And it's up to the programmer to decide, hey, do you want to put it in column major or row major? So yeah, you choose your choice. Not up to me. So let's go back down. Let's test it out. I'll also give it a little print function just for the fun of it. Matrix 4 mat. Now let's create a floating buffer. 16 elements, and this can be fun. Let's do the identity. I'm gonna just speed this up a bit. And that's kind of a bit strange. Did I get that right? Oh, I got 7. There you go. That looks better. More readable. Okay, now we change this one to 1. Change this one at the end because I want the identity matrix basically. Okay. And I'll add a space so that we can do this for separators. Just because it seems like it's actually an alright way to make it more clear. One more. Nah. Right, now let's give our constructor a try. So we're going to pass in buff, which will actually just decompose into a pointer. And let's see if it works, because now I will add a void function called print buff, where we iterate for each. This is the algorithm function. Now this you might think is a funny way of doing it. I just will use a lambda function here. Yeah, I don't know, maybe it is. We'll take in, it's not an int, it's a float. We'll take out the float from the buffer and we'll print it out. And then that's all we have to do. So that's just a nice one-line for loop, kind of like a lambda function in Python. Oh, what's going on? Got a missing colon in here. What line is it? Because I didn't. Oh, so when defining this here, that acts as a statement. So, and then also 103 in the main. I surprisingly forget, it seems, a lot of semicolons at the end of things. I got one more issue. No overloaded function could convert all, which is a little strange because I definitely thought I made it size. Okay, that was the problem. 16. This should match. Float buffer size equals 16. It's just, why is that a float? That should be an int. That's now an int. Int size. Int. And we can make this const. If I did not make this const, we wouldn't be able to specify, like put it in this here, because it would need a const for the size, so it knows at compile time. This is just my way of using that. Okay, right. So we've got our first runtime error of this stream. Okay. Where could that be going wrong? I don't know. There is no description. But what could it be? Well, it's definitely related to what I've just done, and it's probably that there. Oh, I did not recompile. And it's that call there. So this function call is giving me a runtime error. So because we are not throwing any exceptions in our class, I do not know the issue. I will try and look at the issue. So this is the one which I'm doing. I'm looping through. That shouldn't give me a problem, because that would just degrade into... Actually, that might be the... What is this? Buffer? Okay. Just in case that wasn't out of bounds. That wasn't out of... No, it wasn't. Vector subscript out of range. Okay, so yeah, we got some problem there. Okay, let's fix that. So I'm going to put this all in a try catch block. Let's go ahead and try. I don't really, I mean, hey, I guess it's not the lowest to introduce try. Catch. Thinking standard exception. Is there like a general thing? I'm not sure. There's this E function on all the exception objects. No, we shouldn't at least get a line 1931. Okay, yeah, but that's in the source. So, couldn't be this, huh? No, this is fine. Yeah, sorry. It's an out of range. So here, this is the problem. We're going from there to there, size 0 less than this. I mean, it really should be 16, but the problem is something. And we've got 16 elements here. I just change that to 15, see if there's too many initializers? Never heard of that one, huh? 103. 103. Oh, right. Too many. Yeah, because I've got 16 elements. Right. Changing it is going to cause some problems. So first things first is to figure out why my exception is not being caught. Or logged. Because we should be logging it at least, huh? So we got standard exception. It's an exception. This could be why this is not working. I'm surprised it did not throw me an error of sorts. Oh, that is risky to do. Because I've got the file in a header file, so the compiler is not checking my header file to see if there is a problem. So it doesn't know if standard exception is defined or not. So this is really bad practice, actually, because now I'm just bypassing all the compiler's warnings. It seems, huh? Actually, is that even right, what I just said? That's not right. Ignore everything I just said. Sorry. Okay. Okay, again, it's just telling me it's out of range, and like it really shouldn't be out of range because I'm looping from 0 to size up to size. Oh. Of course it's out of range. See, this is the logic which I wanted to run. I'm supposed to reserve. I didn't reserve. There wasn't the space. It's out of the range. Okay. Whatever. Okay. First things first. Let's just print out the buffer size. 0. 0? Huh? Oh, 0 is the number of elements. It's fine. What I want is the capacity. Hang on. Capacity. Elements. Do I still have to reserve and then default? Because there are no elements, it's still undefined. God, making it tricky, huh? This'll work. I think I know the constructor is running. But what I'm confused about, why is my try-catch block not even working? Because here I call E class exception, catch a standard exception. Is there like perhaps logic error, runtime error? Do I have to do standard exception, runtime error? Standard runtime error. Standard runtime error as an object gets passed in. I don't really think I have to do this. This is so... Like, is there something obvious that I'm not doing? Is there anywhere else I'm accessing? It could be here. No, because I'm not... There's no way it's that. It's not that. It's not that. There's no issue with that. Wait. Oh my goodness. If this is true, what that means is that I have not filled the buffer. Okay, there's no equality symbol like that. So instead I'll print out the buffer size. Zero. So the size is 0 because standard fill is not working. Yeah. All right. Is this catch block even running? It's not even running. Because the error is over here. Of course I should have figured that out a little bit sooner. Just indent this. Not that it really actually matters. Vector subscript out of range. Which I know is a vector.add. It's an issue when you actually when you use the app function, or in this case this, but this is unbounded, this doesn't throw an exception, which means that this is the issue. Or this is the issue accessing 0. So here's a quick test. Oh. Hang on. What's the way to catch the default exception? Maybe it's trying to copy. It's definitely, this is not the problem. Maybe it's doing a shallow copy. And the shallow copy is not... No, because my hello print would work. This is really... Try this. So the only thinking in my head is that the issue is not in my thing. The issue is being thrown in the main function. Actually, somewhere here. Yeah. So the issue is coming directly from this call. I mean, that should degrade to a point already. So this isn't going to give me an error, yeah. But this call is the problem. At least I know, obviously, this is the problem. So let's now move our exception here. We can actually do an SP log error. Let's just actually check the get critical. I will stick with error. Okay, you don't want this. Hopefully SPD log is compatible with the return type. Honestly, I am so confused. I think the problem is not even on my side, so the problem is coming from because my exception blocks are not running. So because a standard exception catch should catch all exceptions, if I'm thinks, and because it's not being caught, because my exception is not being caught, I think that the issue is to do with not this. We trace it. Oh, buffer. Sorry. Standard vector reserve. It's a very primitive way of trying to figure out on which line. Do we have to open a debugger? What's so confusing to me is that the catch block is not running. And I have no clue why the catch block is not running. And it's kind of bothering me because I'm now dealing with things which are not. So it seems like reserve is throwing the error. Then why is the catch not running? Past reserve. It's here. This is here. It's here. It's here. But this shouldn't really cause a problem. Because now it will work, no problem. Don't tell me like... Did I recompile? I did. What on earth is going on? Did not recompile. What? What? So this is the issue here. I'm reserving the capacity. I'm not filling it. It has to go after the fill. I can't believe I spent so long. Right? It has to go after fill. This still is not answering the question as to why the catch block isn't running. What is going on? This is a problem. I can't even, after filling, do this because I want to print out the value of begin. So from algorithm, I will use this function. It's called standard distance. It returns an integer that gives me the distance between two iterators. If this distance is 0, fill is not filling the array. I've just passed in a function pointer there. It's 0. It's 0. It's 0. Begin and end are equal, which I tried to check a really long time ago. And because begin and end are equal, fill is not filling the buffer. Because begin and end are equal, begin is to the first element, not dependent on the capacity. So then the question is, how do you why am I not using a list initialize? Why? Why am I not using list initialize with buffer? How many you want? What value? 16, 0.0. 16. That was honestly one of the most stupid moments. I can't believe I was stuck in that for so long. That's gotta be like a sign. I just don't know what's going on. Okay. Oh, that was actually very, very irritating. I try and fill buffer with 16 values, do debug. And the problem was, it's not, hang on, I want to analyze problem. Problem is, end is equal to thing. But if buffer is equal to thing, then standard fill is throwing the exception. Because they're equal. So, I'm going to take a look at standard fill and see if it throws exception when begin is equal to end. Exceptions. If the algorithm fails to allocate, standard bad alloc is thrown. But it wasn't bad alloc, it was an accessing error. And the error was resolved when I did this, so it didn't come from begin and end equaling. It came from trying to do this. Now here, I am using these square brackets. So the problem is not descriptive at all. So if I go back to before I found solution, This still works if I'm right. Good, this still works. This throws the error. But runtime exception is thrown because it's not actually throwing exception in my code. It's throwing exception during the program. It's not throwing an exception on my client side, on my side. I'm not exposed to the exception. The exception is exposed in the implementation side. So if I simply had just changed this to .at, all my problems would have been solved. My exception would have thrown, hello would have come on screen. Hello, invalid vector subscript. If I had just changed that to at. Anyways. So just do not use at, so that if you, especially if you're trying to catch exception. Anyways. Let's just get rid of all these prints and all this stuff. Right, let's use at. Learn my lesson now. So let's get rid of catch as well. We don't need this. Okay, and we don't need reserve, and we can turn this into default with 16 elements 0.0f. Remove the fill, and finally just overwrite those with those in buffer I. Okay, and we're good. Now let's, after initializing, let's call mat.print buff. Did I do it like that? Mat.print buff, print underscore. So here you can see we've got 100, 100, 10, 0. What? 1000. There should be, okay, 4 zeros. Yeah. So it's just so then that's 1, then that's okay. We're good. We're good. All right. This is why I guess it's fine. All right. Now we got the method to print the buffer. We can set the buffer. We've got the buffer. We need to return the pointer to the buffer. So we define a function. Get buff. Const, because we're not modifying the class. Just return buff. Wait, am I storing as member variable? I'm not storing as member variable. Oh, not return buff. God, I've done this confusingly. Return buffer data. Return cannot convert. I thought it returns a pointer to the underlying type, but it's saying that because it's a template class, it does not work like that. So, what is the solution to this? Because it's const, that might be the problem. Okay. It wasn't the type which was the problem, it was the fact that the consts weren't lining up. So now we got another method to get the buffer. It's from the beginning. This. Honestly, this is so annoying. I hate that I did it that way. Let's go back to list initializer. Alright, great. This wasn't actually that hard if I had, you know. Where am I up to? So I got access to the buffer that's needed because when we upload data to the OpenGL, we need to give it in that form. Okay, cool. So next up is to get in our vertex shader. Let's write a uniform. So we want a uniform, we want it to be a mat4, and then we're going to take a model and we're going to try and scale it using our new matrix that we just created. Right. There's our buffer. And I will get like a set scale. I will have to overload the matrix multiplication. Writing a math function is so much more complex than I first thought. Okay, anyways, we want to get the GL uniform location, which is in the form of an unsigned integer. So model location. You can actually do this in one call, but not necessarily. Let's go back to our specification. So the program and then the name of the uniform. And it's not an unsigned int, that's to be aware. It's actually an int, so we'll just do GL int. Now we just need to upload. You do that with GL uniform mat. Let's find out. Uniform mat matrix. Uniform matrix. I like the table. Where's the table at? Ah, here we go. 3FE. So I think we want 4FE. They just write it like this, 2, 3, 4. So then we need the location, the count, which will be 1. Is it do we want to transpose it when sending it? No. And the data, which we will actually be using not the raw buffer I defined, but the mat.getBuff. Don't transpose it. No. Mat.getBuff. This should now update our program with the model matrix that has got our scaling. And our triangle is now invisible. Right. The issue is that when you are doing all this setting, the context needs to know which program it's doing it to. And I think, yes, you get the uniform location from program, but if there's no bound matrix when you call this, it won't know which program object to set that value for. So I think we have to use the program before we do that call. There it is. Right, now let's check if that is working. I we'll, instead of doing this way that I'm manipulating it now, I would now just do some operator overloading where I can define multiplication with a scalar for the matrix. So if we remember the function call, we will do operator and then the operator which we want, which will be a multiplication. And I want to define it with a scalar, which would scale like this. And on the left hand side is implicitly this. And I think it does that. And then we'll use our one line for loop to go throughout the buffer. This time not taking just I, but a reference to I. That reference will let us modify it. And we will just do I times scale. I equals I times scale. I times equals. Okay, so issue here is probably with the operator. And it's saying that, let's see, so this is in matrix 4, 21, 5, so yeah, it's this here. And the issue is missing type specifier. Oh, here, sorry. Missing type specifier. So the lambda is like a local scope, right? Even though we're calling it in a function which says scale, it doesn't have scale. So we need to put the scale in our capture list. So I want to capture a float. Actually, I think you can just list scale like that because still got the same issue. However, scale cannot be implicitly captured because no default capture mode has been specified. I could solve all my problems by just doing by reference with everything, but I will not. So this will copy the value of scale. No, it won't. I don't think it will. Does it copy? Does it not? Not got the current issue, so now we've got this. I feel like looking up this one. It's just apparently a warning. The warning is issued when type specifier is missing in declaration. Void operator. Here we go. So we're not saying what we're returning from this operator call, and what we want to be returning is a reference to the matrix itself. So we will do this just by saying matrix 4 4. I just didn't realize that. Okay, nice. Now we've got multiplication with a scale value. So we can go back into main and mat times 3.0 2.0f should now be defined. No operator found. So binary operator. So this is the one, 2 arguments. Takes our right hand operand. I'm literally just doing this out of interest to see if it will solve it if I put it as the left hand. Okay. So we're gonna have to go back and look at how we're defining this. Defining a reference, and we're taking this, but do. I always thought that they implicitly call on the function which you call it from. So it's like the mat times. So I thought that mat times 1.2f would work. Oh no. But apparently I have not defined that correctly. So let's take a look at this compiler error, and hopefully the thing will remind me how to correctly define this. Just overload it for the specified type, but define a conversion to a type. Constructor with int c equals 10. Yeah, that's it. There it's implicitly calling this, which just does nothing. Here there is no definition. Okay, it's not really helping, but what I really need is now to relook at operating overloading. Because I've forgotten clearly how to do this. So in this struct, we will just ignore the fact that it's a thing. So this is defining that operator. Taking in, okay, so that's all. I just forgot that I have to specify the left-hand side and the right-hand side. So my left-hand side, is that right? To like that. I wonder if that's right. Yeah, it's a binary operator, which means it's just already implicitly being called on the matrix against a scalar. Oh, I feel like this is just another dumb one that I've done. Capture the scale. Ah. That's for moving, which I'm not interested in. Maybe I have to look at this definition. Can operator times be overloaded? Actually is a good question, because there's a chance it can't. Times cannot be overloaded, so oops. So realistically, all I really had to do is just change it from times to something else. Now what that would be, there might just be a better way, which is to set it up as a function that returns thing. I'll call the function scale. Does it make sense to do mat.scale, mat equals mat.scale with a number? Yeah, that's fine. We'll take a const float, not that it really matters. Call that the scalar. And then we'll do our lambda. And we'll capture the scalar. And I'm just so curious that capture list. I think this implicitly captures everything by reference. But I think it does. So, and I is captured by coffee. Okay. So it actually doesn't implicitly capture by reference. Which begs the question, why do you have to put this in the copy section? Anyways. I times equals scaling. Did I update main to remove this? Mat.scale. And then you just put in the scale. I kind of prefer it like that as an implicit call. I don't really want to reassign. So should I return a reference? I am ignoring the reference, and it should still be able to must return a value. Oh, because I'm telling it to return this dereferenced. Okay, great. I can ignore it. Now, for the sake of it, let's just call this print buff. Inside. Not that I actually need to refer to print buff because we're already inside, but you can see that we're not scaling correctly here, and I think part of the problem is that this is not taking by reference, so let's take by reference. Yeah, so now we're scaling. See that it said 3 thing? So nice. Mat.scale is now working. Okay. So we're scaling the underlying buffer, no problem. Which is our vector. And let's go in the vector. What am I thinking? Okay. So window named graphics window. Right, now just the next problem is why are we not scaling these vertices? So if I set it to be 5, I want all those vertices to scale out. Okay, so let me tell you what I think right now. Let's just check that we are compiling the right thing. So we've got a uniform mat form model, and we are timesing the vector by the model. So you might wonder, what is the problem? Well, here we are uploading and we're using, just in case this is the problem. Let's use before we do anything with uniforms. So that wasn't a problem. Now the problem could be that I have specified the wrong like column major versus row major. That is not the problem. Let's just double check that the buff is correct. We're still good. Okay, so honestly now I'm thinking, did I set up get buff wrong? Because I am supposed to be uploading to this thing for FE. I know that there is this nice table here. I think I might be... I did look at this in the spec. We are supposed to have a const reference to the buffer. So what is the issue then? Honestly, things look fine. The buffer is fine. Data to the buffer is fine. Could it be data? Could it be count? Did I get count wrong? Yeah, this is gonna be, I'm gonna need uniform. So we can see that the count there, size I, load count sets, one set. That's load count. Yeah. You can see here if transpose is false, we're in column major. So I do just want to load one. Wow. What is the problem here? I mean, I don't even know the problem. Because this isn't really unclear because I've got the location from the program. I'm multiplying everything in vec3 apos model times. Okay, let me try scale that by 2 inside here. Is there an issue with my... This is wrong. This is not even scaling. What? 1 by 1 by 4 by 1. So my integer has to be on the right hand side? Because it's 3 by 1 times 1 by... No. Huh? What the hell is going on? Uniform map for model. Vector 4. Wait a second. Vector 4. Vector 4. 1, 2, 3, 4, 5, 16. Set the scale. Use the program. Okay, I kind of think I want some logging in my math files. So I know that the stuff in the buffer is fine. This is a very confusing problem because I've never had this before. And there's no error message. It's a runtime problem and it's silent and it's behavior based. So, one way I can check that the vertex shader is actually working is by directly changing this vertex data. And yeah, so my vertex shader is definitely working because it's taking in those vertices and passing them through the pipeline. But the scaling of the vertices is not working. 4 by 4 times 4 by 1 times by my model. damn. Yeah. I actually have no idea. Let's take a look at some details then. So there might be something which I don't understand silently. So this command returns name. If name is null terminated. Wait, what? No. Location. The value will be -1. Let's check. Why am I doing cout? I can just do spd log info location. Model location 0. 0? It shouldn't be 0, should it? It doesn't say anything on it being 0. It seems like 0 is fine. If I expect it to go from 0 upwards. If I manually change this, I know that won't work. Oh, it worked. Wait, what? That noise was horrible. Sorry. Right, so the problem here is with the buffer. My scaling function is not working. But I am passing the right buffer. I want to make sure I'm not holding onto a pointer to the data. And I'm not. Because I copy in with this constructor that data. So we're fine there. But the problem is with the scale function. Particularly that this is not correctly mutating the elements in my buffer. Despite this, whoa. Despite there's so many like little bugs that happen with C++. Could it be I'm capturing I here by reference? No, that's not a capture list. My issue is probably definitely with the way I'm using a lambda function. I think I'm using it slightly off. What am I? Because it implicitly passes for each this unary function f, apply this unary function to each dereferenced iteration in that range. And it doesn't. Here's the problem. What if it's being passed as the scalar in the capsule? Right, we can check if that's, but I know it's modifying the underlying buffer because here when we print after the modification using this print buff, it's printing the modified value. Function object to be applied to the result or dereferencing every iteration in the range. The signature does not need to have const. The type must be such that an object print, apply the print function. And this is a lambda which is taking constant n. But reference, no problem there. And then I'm timesing I by a scalar, also no problem. I is equal to I times scalar. Oh man, what? And even damn. Increment elements in place. I have literally done that. I don't see a problem. Not defined as a cost, nothing like that. How weird. Wow. I literally can't figure it out. Because this is working. And it's even showing that it's using the 2, scaling it up by 5. Oh, I really want to know why that's not working. What if I just gonna do a usual for loop up to 16, and then I'm going to call my get buff like this. Now I'm going to print out this. Says, oh, buff is fine. Can't float star. Could be no problem. Oh my goodness. This is so weird. Because none of it is making sense. Could it be when I compile? I am shocked at... This is confusing. I actually might have to use AI to figure this one out. I need to take a little break. Hey, that's a break over. Also, I just realized if I set that true or false, the transpose, it doesn't matter, right? Identity transpose is identity. Anything diagonal matrix. So let's run through what could be the problem. What could be the problem? Well, I'm using the program, no problem. I'm calling getBuff, no problem. Let's try passing the raw pointer. That works, no problem. Let's try call mat.getBuff. That's working. Hold on. How many times is my constructor running? That's one. I only want that to run once. I'm not like constructing anything that I don't want to be constructed. I've got a function that returns a reference to matrix. And I'm scaling it by some constant scale. I've got this, which is supposed to be affecting the underlying buffer. I return a pointer to this object, but then I ignore it. A reference. So mat.getBuff is over here. Returning buffer.data convert star. Should be returning the pointer to the first element. However, it's not. Something really strange is going on. Like really weird. This is so weird. I am going to just do that. I know that's the same thing, not one. But I just have no clue what else to do. Wish someone could tell me what to do. Oh man. I can't solve this. I'm stuck. I don't actually know if this is a problem with Opengl or my C++. I think it's a problem with my C++. Let's just think about how we're passing these pointers. Here I'm passing a pointer to buff. I'm passing a pointer to buff. No, I'm copying the pointer here. This is taking the pointer by copy. Let's find out. It's taking a copy of the pointer. Then I dereference the pointer. And I start taking out some values and assigning them to... Oh my god. Oh my god. Whoa. So basically what's going on is that buffer.add_I returns a reference. Then I'm basically saying, take this reference of this object and assign it to the value from this pointer. So now I've got a reference to a value in this buffer here. I don't have a copy of the value like I wanted, rather a reference to it. So to fix this really weird bug, I just will take a copy like this. And I simply have to just do this. This will fix it. I wrote redeclaration. Oops. That is actually such a strange bug right there. Like, is there a way to do that in place? No, I'm not sure. I don't know. Okay, so I'm now taking a copy of buff plus I. So let's see out. Copy. Just make sure that we're getting like the same values. Should be like 2, yeah. So starting off with 2, and then I'm assigning it. Fantastic. Okay. That's good. Now the reference. Wait. Okay. That's good, right? Because I'm now just taking a copy. I'm not. I'm assigning a. Assigning the reference just to buffer.mi equals copy. And copy goes out of scope. Okay, so we're starting off with 2000. It's scaled up to something. I think that's fixed. So then the question is, am I now... Okay, so if I think that that's fixed, let's go ahead and do one there. Alright, we're back to our tiny triangle. So we haven't fixed it fully yet, but we got close. Alright, now we have to address this. So like before, have I solved the problem? Because I could still be taking a reference. I'm clearly not. I'm clearly copying by value. There should be no references, no nothing. And just to be sure. So this should be doing a move operation, maybe underlying, because it's assigning to a reference. This is a really hard problem. I have not ever had a problem like this. It is this hard to solve. I want to do a raw delete call. I'm not deleting, but I can delete this array if I just change the way I'm doing it. So the reason I'm doing this is because I'm trying to see if the problem is a pointer problem. Okay. Oh, then I'm gonna have to write over it using pointer arithmetic. That is a pain. No, because then I'm gonna have to use modulo to set. There's just so many different facets. Do I have another option which is simpler? Can I just call delete on this? Probably. There's not a problem doing that, right? Like, I just comment out all this stuff to do with model. Of which there is quite a lot. And then okay, there is a problem. Not deleting that correctly. Okay, let's see. That's I forgot about that. Okay, hold on. I think I'm mixing things up here. This is dynamically allocated, which means it's not allocated in the same way on the heap. So this is managed for me. Because it's not a raw new call, so there wouldn't be a raw delete call. Oh. This is assigning the data. Apparently they're all equivalent, he said. What am I on? That looks cool. Processing. I don't feel like I'm getting anywhere with this. So that's right. So this is dynamically allocated memory. This is for memory allocated on the heap. Because of this, which means that there is another way to do that. So how to delete? Wait a sec. think if I... It's just, I know that. Oh my god. Oh. There's no reference to be taken here. I am lost at what the issue is. That should help. Now we're disappearing because we're 2, 2, 2, 2, 2. There's just some weird thing going on with this copy. It's referencing the underlying the buffer from main and causing all sorts of problems. I'm just trying to allocate it. So here's what I'm going to do. If I modulo 4 equals 0, this will basically set it up. I modulo 4 is 0, 1, 0, 0, 0, and then I modulo 4, and then we want to plus I modulo right. So 4 plus I modulo 4, so this is 4. Then on the next, when we get to 0, 0, 4, 4, I did not do that. Damn. Okay. I'm just going to set it manually. Buffer dot at 0 equals 2. Then it should be the 4th element. No. 1, 2, 3, 4, 5. 5th element. That should be enough to demonstrate it's working. It's working. That is tall, which means it's working. Now it should get wider. It's wider. Great. This is the problem. Float stub off. Pointer. Dereference the pointer. Take the value and put it into a constant int. Not a reference, but it's taking it as a reference. But, okay. So I need to find a new way how to write to standard vector, not reference. Because it's returning reference, right? It's causing a very big problem. Because I don't want it to return a reference. I want to watch that video. I want to watch that video. Damn, this kind of looks like my situation. This is exactly my situation. I mean, this guy kind of was a bit, you know what he's talking about. But they're saying to create a wrapper class. I don't want to do that. I want to write to the reference. How to write from a pointer into a vector. I don't want to use ChatGPT, but I know ChatGPT will know the solution. But I want to find the solution myself. Print buff is accessing is a reference. What is being put in is the element. The element comes from the pointer. I need to cut the chain somewhere. Here. Float star buff. Then. Let's just create a new buffer, maybe. This is going to be such a bad solution, but no, isn't that just propagating the problem again? Int t equals 6. Vector p, pointer, and then refer p as the memory address of cool. And push back to cool. It's not. Like, problem of storing vectors in a container, and a bug. I feel like this guy is maybe doing what many would find the conclusion that it should not store pointers. When you have issues with down, so you got, this is an array of pointers. I don't have an array of pointers. I got an array of floats. Let's just come back to the problem later. I'm not getting anywhere with it. I'll try one more time. This should be the thing that cuts the change. We should be taking copy now. That's why I wrote copy. But we're not taking a copy. No. Something very, very weird is going on. I don't really want to know. I've never heard of this. Can I fight the urge to use ChatGPT to figure this out? Do I need to? I mean, the whole point was that I don't use AI in this creating Minecraft. And I just do everything from scratch, including camera and math libraries and stuff. So I will work on this problem in the future when I come back tomorrow. So goodbye everyone for now. We did not get entirely far. To recap, what happened today was I showed everyone how to set up cmake problem, how to declare these third-party dependencies which have cmake lists. Using git, I did not really. Oops, that is really not good. So I need to add external here as well. Okay, that will do. Now I need to status because I just added all this, and now externals in here. We don't want external to be in there, so we have to reset the stage. So yeah, look, use git restore stage file to unstage. I wonder if I can pass it a directory maybe. To unstage. All changes. You have to be really careful because if you write git reset dash dash head hard, because I have not done a commit on this. Actually, I did one commit, but that's all the way at the start. They're very careful. You need to be very, very careful here. Do not run git reset hard. This is 100% correct. I did this and I lost everything. We'll revert any changes in the working directory. Git reset. If all you want to do is undo this git add, your changes will be unstaged and ready for you to re-add. I'm scared though because I accidentally did this. Okay, yeah, we're fine. No changes and we're fine. Now external should have now been out, so let's go ahead and implement our changes. So math library has been made. Basic setup. And yeah, not too much else, huh? Honestly, not too much else. Because I have a big bug. Is there a way to create an issue in the Git CLI? Because I know you can do it on GitHub, create an issue. Not on GitHub, not on Git, just in Git. Sorry, God, I can't speak, huh? How to create an issue in Git CLI? This is GitHub, so you can't. That is actually a really useful one. Oh. Okay, so that will be all then. Doesn't look like there is a git command to do that. I will do my own research in my own time. The thing about this whole whatever Minecraft from scratch is everything in the project will stay the same. So I'm not going to work on this project off the stream because it kind of defeats the point of being on the stream, like being transparent about the issues which I'm facing, how I deal with them, and just working with from what I currently have and not trying to demonstrate and show anything which I am unable to do. You know, like cut the shit. Okay, thank you and goodbye.